making sense out of sensors. I'm going to head through this pretty quickly, so try to keep up. All right, so how do we communicate? Well, back in the day, we communicated on cave walls. As years went by, we improved our tools, but, it never really changed that much. Although, for now, we have sensors underneath the hood of a car or underneath the car that tells the PCM, what's going on with the engine. So we have these input sensors that control outputs, okay? So I'm not really talking about the output side. I'm just talking about the input side. Quite honestly, they all basically do the same thing. So how does the computer know what's going on under the hood? Well, it looks for a changing voltage, okay? So how do we change the voltage? Usually we do it with some type of resistance or, some type of a pulse or, there's really only a couple of different ways. So we look at, like pull up. This is really common. When the PCM has a 5 volt or voltage reference coming out of it, or this could be straight 12 volts, up to some type of a switch or resistance in the line. And then inside the PCM, there's what's called a compander. And basically all that is just a voltage reading, device. It's kind of like a DVOM, except there's no display on it. Anyways, so this pull up voltage, when this switch closes, this line here at the compander goes high. Now we put a resistor on here, this resistor, this dropping resistor, so that when we open this switch, this wire could be out underneath the hood, we could get all kinds of extraneous voltage on this line, which could confuse the computer. So when this switch opens, the resistor's job is to pull this line back down to 0. Okay? This is called a current source switch. And we also have a current sink switch or a pull down switch. And all this is we have 5 volts traveling through a dropping resistor again, and then the switch or the resistance is put to ground. So we close the switch, this guy should go to 0 volts. We open this guy, it'll go to 5 volts. Well, why is this resistor right here? Well, this is to control amperage now, okay? Because we don't, if we close the switch, we're going to lose our 5 volts without this resistor in. We're going to lose the 5 volts back here, and this 5 volts probably runs a whole bunch of reference voltage equipment, TPS and coolant temp, and all these other ones utilize the same 5 volt regulator. Why is it 5 volts? That's pretty much a standard nowadays, although don't get too caught up in it, because I've seen some weird ones that are 9 volts or 8 volts or whatever. And you need to go check the service information. All right. And we also use what's called the resistor network. And I'm picking on, this is Ford's MLP, which is a manual position lever. And really all this is the same thing. I've got some type of a, power fed through here, which is pulled down, to ground as I add, in park it would be the lowest amount of voltage because I have the most resistance. I switch it into reverse and I have less. I switch it into 1 and it has even less. So the voltage would come up on this line as I shifted the gears from park to first gear. Okay? So if we look at it, it has a certain amount of resistance between these two pins 46 and pin 30 in this particular plug. Okay? And if we look at it, it has a range in it because, we're using resistance, and as the temperature changes, the resistance changes of the resistor network. So that's why we have a range like this. And if we look at it, this is about what you'd see, if you were monitoring this line. And if you notice, there's only a small amount of voltage in here, voltage difference in here. Now, this is a 5 volt reference device. And I can tell that because I'm at 4.4 volts. Now, notice that it never goes all the way to its reference voltage, 5 volts, and it never gets pulled down to 0 volts. There's always some left over. Why? Well, if it's not designed to. So if the computer ever saw 5 volts or 0 volts on this line, that's where the check engine light comes on. This is where a code is developed. It's out of its manufacturer tolerance. it sees 0 volts. Well, it's not designed that way. We'll turn on the light. Get it? So these temperature sensors do the same thing, and it's just a varying resistance to ground pulling down this reference voltage on whatever it is. So here it is, another 5-volt reference device. This is a pull down, right? Because one side goes to ground, the other side comes up here to my pull-up resistor, right? So as the resistance on this guy drops, the voltage goes down. We okay? So what happens if I unplug it? Well, it's going to go to 5 volts. Check engine light. What if it gets shorted to ground along this line right here? Well, it's going to go to 0 volts. Check engine light. Get it? All right. So one of the things I can do to check my ECT, my coolant temperature, a lot of times there's more than one ECT available. Okay? Or there's more than one temperature sensor available, especially if the car is cold soaked, it's been sitting for a long time. I can check and make sure that IAT is the same temperature as ECT. Usually there's a T transmission temperature, the T, whatever it is, the temperature transmission sensor. All those guys should be about the same, and if one's off, well, then there you go. That one's probably bad. All right, GM has been using this for years. They've been using this since, the 90s. Most manufacturers are using something like this. And if you notice, here's my sensor input, right? And then here's my ground that runs out to my ECT. So this 5-volt reference is actually switched between these two resistors. Below 50 degrees centigrade, about 160 degrees, it's got 2 in series. When it's above that, it's only got 1. Well, why would they do that? Well, look at the temperature curve on this guy. Think of it as a second gear, okay? As the temperature rises, the voltage gets dragged down, and then it switches over to the second gear, pops back up, and then it drops again as it continues to heat up. Well, why would they do this? Well, it gives us a much finer resolution. And this is one on a 2001 Jeep Wrangler that I watched over, I don't know, about 15 minutes or so. Okay? So this is a warm-up cycle of this guy. And as you can see, the voltage on the ECT dropped and dropped and dropped, and then it reached this point right here where it just has these humps. And if you were to look at it, they would continue to go out. So what is that? Well, that's actually the thermostat opening and closing. Get it? On Tier 2, OBD2, the Tier 2 stuff, they needed to have a way to test thermostats. So this is how they did it, is by using a real high-resolution coolant temperature sensor. So they were able to monitor that the thermostat would open and close. And it would, just gave them just a whole bunch finer focus of information on the temperature of the engine, because it's a critical parameter. Throttle position sensors, TPSs, and, gosh, God love them, they all work the same way. I get any type of position sensor like this. Some of them are going to a Hall effects. We'll talk about that in a second. But honestly, there's 3 wires to this guy. It's power, ground, and signal. Well, I got 5 volts coming in. I got ground on the other side and a variable resistor in between the two. And that's what the signal line was out. That's what the signal line is connected to, is this wiper. Get it? So all this is just variable position, variable resistance based on position. It's also gives us a great place to check for 5 volts. Usually throttle position sensors, TPSs, are easy to get to. And then I can also check my sensor ground at the same spot. If I got a question about whether or not my 5 volts is okay or whether or not my ground is okay, this is where I'm headed, usually the TPS, because it's easy to get to. Okay? Thankfully, we really don't have this problem too much anymore, but realize back in the day we had this problem a lot with these TPSs. So, a low voltage would be closed throttle. And as you open the throttle, the voltage goes up, and then you take your foot off of it, the voltage would come back down. Well, if this thing got glitchy, what does the computer think you did at this point? It thinks you lifted off the throttle, stabbed it again, lifted off the throttle, stabbed it again, lifted off the throttle, and then floored it. Imagine what that would do to fuel or ignition or, right? Thankfully, we don't have too much of this problem anymore. Although they've gotten really good at catching it and blowing a code for it. You know, watches RPM rise, and then all of a sudden it shows you taking your foot off the gas, but mass airflow and map are still agreeing that you're into the throttle. Code for the TPS. Okay. Map. Map manifold absolute pressure. This measures manifold pressure. Now, the cool part is it also measures manifold pressure is generally a negative pressure, a vacuum. So what's a vacuum? A vacuum is anything that's below atmospheric pressure. What's atmospheric pressure? Well, around here, about 14 psi, which varies a little bit. Okay? Atmospheric pressure varies. Did you ever watch The Weather Guy? You see the big H coming in. You see the big L coming in. That's barometric pressure, right? So that line, that zero line between vacuum and positive pressure, does float a little bit. We okay? Now, the other thing that they use this for, anyways, here, let me get through this. Map, decrease in manifold vacuum means an increase in manifold pressure. And it compares it to a perfect vacuum. There's a little vacuum chamber inside there. Usually they use like a silicon wafer, and that changes the resistance, which, so the pressure differential changes the resistance of the sensor, which changes the signal voltage output. Sounds just like a TPS is set up, right? Same thing. That's a picture inside one. All right, so here. Normal engine vacuum, 17 to 21 inches of vacuum. And a normal map sensor voltage is between 0.88 and 1.62 volts. And this is GM, and this is pretty accurate for anybody. Anybody who's using a 5-volt reference is kind of how they divide it up. Therefore, a good reading should be about a volt. But remember, this is a 5-volt sensor. Okay? This is 5 volts. What do they do with the rest